Hello, I am Sourabh Ranjan Kar, student of ADTA 5550, Deep Learning with Big Data. This is my final project. Our project is about convolutional neural networks, CNN, on CFAR 10 dataset. In this project, I'll be representing my project work, which I have done. In this project overview, I'll first introduce what all in my project is there. Second, project main goal and dataset description. Then the architecture which my project is based on, then how my convolutional neural network performance is improved. Now, the main thing is what is CNNS? A convolutional neural network, commonly known as CNN, a class of deep learning algorithm that have revolutionized the way computers see and understand images. These networks are inspired by the biological processes in the human brain and are particularly adept at processing visual data. Much like the neurons in our visual cortex that respond to light in specific regions of our field of view, CNNs have layers of artificial neurons that activate in response to patterns in visual data. They have been trained to recognize shapes, colors, textures, mimicking the way we see the world, like the humans see the world. At the heart of the CNN, there are multiple layers that each play a role in interpreting image data. These include convolutional layers that filters images for features, pooling layers that reduces dimensionality, and fully connected layers that classify images into category based on the features extracted. Each convolutional layers in a CNN uses a set of filters that have weights. These weights are learned through exposures to countless images during the training process. As the network processes more images, it adjusts the weights to minimize errors, getting better at identifying what it sees. CNNs are behind many technologies we use every day, from facial recognition in security system to the filters in our cameras that make us look like cute animals. Like filters, like people take, let us take example Snapchat, use filters that also uses CNN, and CNN is incredibly becoming part of our daily digital experiences. Then in my project, this is my architecture based on CFAR 10 dataset. In this architecture, I'll explain everything what it is and how it is, and taking care of all the things. There are layers in senior architecture based on C14 dataset. Layer configuration, convolutional layers, as I said and before. ReLU activation, pooling layers, fully connected layers, dropout, and hyperparameters. Layer configuration means the architecture includes several layers, each designed to a specific function. Convolutional layers means these layers apply a number of filters to the input images to create a feature map that captures the presence of spatial features such as edges. ReLU activation following convolution, the ReLU rectified linear unit activation functions introduces non-linearity, allowing the model to learn complex patterns. Pooling layers means pooling reduces the dimensionality of each feature's map while retaining the most essential information, improving computational efficiency and feature detection. Fully connected layers mean these layers placed towards the end of the network perform classification based on the features extracted and reduced by previous layers. Dropout means implemented to prevent overfitting by randomly dropping units along with the connections from the neural network during training. And last is hyperparameters. With the choice of hyperparameters such as filter sizes, number of filters, pooling window size, and dropout rate, explaining how they influencing the model's training and everything. Uh, in my this architecture, They are configuration of the first convolutional layer adopt a 4D shape with a batch height width of 132, 32, 32, processing 2D data with a size of 32 into 32. Input and output, it takes an input shape of 32 into 32 into 3, where 3 represent RGB color, means red, green, and blue color channels, and generates an output shape of 32 into 32 into 32. Filter and stride utilizes a filter size of 5 into 5 with shape filter 5532 32 with a stride of 1. Stride shape is 1 of 1 of 1 of 1 and employs same padding for maintaining the output size. Activation function implements the rectified linear unit. This is ReLU for non-linear activation. It has layer 1 input and output, maintains the input shape at 32 into 32 and 32, and output the same shape, utilizing the ReLU activation functions for introducing non-linearity. There's pooling layer 1, which helps to apply 2 into 2 window size, and the window shape is 1, 2, 2, 1, with a stride of 2. Shape size is 1, 2, 2, 1, and the same padding, effectively reducing the spatial dimensions. And when we come about depth, processes 32 unit input channels and output 32 channels. The spatial dimensions of the output reduced to 16 into 16 to 16 into 32, enabling features downsampling while retaining important information. And then we come in a phase two, which really means like how training the scene and taking out the most out of it. In training, we take care of the optimization loss. The Atom optimizer is used for its efficiency in adjusting the learning rate during training. Softmax cross entropy is selected as the loss function to calculate the difference between the predicted probabilities and the actual distribution. Batch training, we have the training process involves iterating over many batches over the dataset over the dataset, where each batch is passed through the networks to compute the loss, followed by a backpropagation step by update the model's weight. Performance evaluation and compromisation means depend on accuracy measurement. The model's performance is taken care of the performance evaluation and comparison. Then what I feel like then that's train the convolutional neural network. It has data setup, variable initialization, training loop, batch training, and periodic evaluation. In data setup, loaded and configured the CIFAR10 dataset using the CIFAR helper class. In variable initialization, initialized all the variables within the TensorFlow session. In training loop, implemented a loop for predefined number of steps, such as 5,000. And batch training, as I have taken a quarter batch of training data using the next batch method and used it in a train the neural network via the optimizer. In periodic evaluation at intervals of every 100 steps, assess the accuracy of the model on the test sets. Then it comes to improved version of convolutional neural network, and this in improved in improved architecture, we have added one extra layer which help to improve performance on CNN on C4 dataset. In C4 dataset, then it helps to improve the performance of the CNN on the C4 dataset. I recommend incorporating an additional convolution layer and a corresponding pooling layer. This entails an extra step to extract more intricate image features enabling the network to identify complex patterns that might have been previously overlooked. Think of it as enhancing the model's ability by adding an extra pair of eyes to scrutinize the data more closely. Furthermore, the additional pooling layer simplifies the information without sacrificing critical details. It's help to summarizing the lengthy help to crucial points. This step prevents the network from becoming overwhelmed by excessive information and allows it to concentrate on the most significant aspects of the data. In phase one, we have enhanced scene architecture. We added a second convolutional layer equipped with 64 filters and size with 5x5 with ReLU activation for enhanced feature recognition. Implemented an additional max pooling layer to further refine feature extraction. Introduced a flattened layer to prepare the data for subsequent fully connected layers. Incorporated a fully connected layer comprising 1024 units, employing ReLU activation to capture intricate patterns. Introduced a dropout layer for regularization, strategically dropping inputs during training to prevent overfitting. Concluded with the final output layers as a FC layer, leveraging dropout layers of outputs for precise predictions. Defined a loss function using softmax cross entropy to evaluate prediction accuracy and effectively. And I'll take to my report and tell you, and I'll explain my report now. It's taking a little bit time. Um, in this we have 8 parts. The part one we have uh, does student require to use TensorFlow directly encoding? Yes, we will use to build train and test CNN. And in second question we have is the student required not to use? No, we no we will not use the keras encoding. In part two we need it we need to select the data set which has the images. So I have chosen bird image classification data set from Kaggle. Um, it has 525 species of bird images, and the dataset has a description. This dataset is filled with pictures of birds. It helps it helps to teach computers to identify different bird types. It has 525 diverse bird species with 84,635 pictures to train the computer. Also, there are 2,625 pictures for testing and another 2,625 for confirming learning. For every bird type, 5 images are the test and validation test sets. Each image has one bird, taking up most of the frame. All images are the same size, up to 24 into 224 pixels, vibrant and stored in JPG format. They are grouped into 3 parts: training, testing, and validation. Within these parts, 525 tiny folders exist for all birds types, which aids working with Python. An additional file with birds.csv comes with the dataset. It gives crucial details like image location, bird common size, and scientific names, and ID numerals, which will help us to differentiate the unique type. It has content of, as said, 89,885 images, where from 89,885, 84,635 training images, 2,625 test images, and 2,625 validation images. These all are the image details, as it has a format of JPG and dimensions of 224 pixels. And as said, color channels are always 3 channel with red, green, and blue. Now we'll go to part 3. As in part 3, we obtain a CPAT and dataset which is available in our Canvas portal, where we need to download the CPAT 10 dataset, and we need to upload it to the remote server in the Google Cloud platform. So I have downloaded and uploaded successfully in my remote server, as you can see in my screenshot, as it needed to uh, get into a specific folder named CPAR10 dataset, and I have used the function of directly uploaded, and for copying the file from the root directory to the main folder, we use cp command to copy, and it had 7 files, and I have moved all the 7 files from the root directory to the relevant directory for the processing. As the main thing is, it comes with, like, after that, as I explained, it has the architecture with input layer, convolution layer, and pooling layer, and we need to flatten and connect the output layer at the left and the fully connected layer to the right. It has convolution layer created in the initial revolution layer with 32 filters, each having a size of 5 to 5. Applied the rectified linear unit. Activation function after convolution. Pooling layer added the first pooling layer, working on in conjunction with the first convolutional layer. Max pooling and flattening. Implemented max pooling and followed it with a flattening layer. This step prepares the data for the subsequent fully connected layers. Fully connected layers introduce the fully connected dense layer using the flattened data as input. Dropout for regularization. Applied a dropout layer after the fully connected layers. This layer randomly drops a fraction of inputs during training to prevent overfitting. Final output layers establish the final output layers as another fully connected layers. Utilize the outputs from the dropout layers as input to produce the final predictions. Loss functions defined as softmax cause entropy loss functions. This function quantifies the dissimilarity between predicted probabilities and actual levels. Optimizer selection setup. Optimizer specifically uh, the Adam optimizer to minimize the loss. And I said we need to train the convolutional neural network, where we need data setup, variable initialization, training loop, and batch training, and periodic evaluation. In dataset, we loaded the configured the CIFAR 10 dataset using the Cipher helper class. Variable initialization we used within TensorFlow session, and training loop we implemented predefined number of steps such as per thousand. In batch training, we have acquired batch of training data using next batch method and used it to train the neural network via the optimizer. Periodic evaluation is evaluation we calculate the accuracy, and we have taken in every 100 steps. 100 steps. This is the accuracy of the model on the test set. Now I'll explain the part for coding, and subsequently. So this is part for coding. In part for coding, first we need to set the path for the data folder where we have stored the data. As in the last report, I was explained that we downloaded the 7th file from our canvas. So after setting the path folder, we need to define the directory where the cpart10 dataset is stored. And this step is crucial for accessing dataset files for pre-processing and model training. Then we need to load the data, and for loading the data, we have used custom functions unpickle to load the cpart10 dataset batches. This function utilizes the pickle module to deserialize the dataset files into a Python dictionary format, making the data accessible for processing, as you can see. And then explore the data. We have to explore the data, display images from the dataset using matplotlib. to visually inspect the understand the nature of the CPAT and data set. This is the it's a Python library which helps us to visualize the data parent format and yeah, then implement a series of functions from data processing. One hot encoding of labels, convert category labels into binary class matrix. Necessary for classification of CNN, image data setup, organize and reshape the image data to fit the model's input requirements, including reshaping images and normalizing pixel values, cipher helper classes. Then then we came to set up the image data, make it ready to be fed into first convolutional layer, build a scene model, construct a scene, like it'll construct architecture using TensorFlow. This helps to initialize weights and biases, creating convolutional layer and architecture features with the images, applying ReLU activation functions to introduce nonlinearity, implementing pooling layers to reduce spatial dimensions and control overfitting. Here we have I said we'll use Cipher helper classes to streamline the process of batching and preparing the Cipher 10 images and labels for training and testing the scene model. Then we'll define the supporting functions to build, train, and test CNN model. For train and test model, we execute the training and testing phases within the TensorFlow session. This including installation or variables, running the training loop for a defined number of steps, feeding batches of images and labels into the model, and performing backpropagation to adjust the model weights. Evaluating the model's accuracy periodically on a test monitor performance improvements over training iteration. Accuracy and evaluation. We assess the model's performance by calculating the accuracy metrics, comparing the predicted labels against the ruled true labels of the test data. We have the steps where determine the propagation of prediction over the total number of prediction to gauge the model's ability to generalize the unseen data. Now, like we have as it has in this lesson biasness, as I said, it has convolution layer and perform convolution computation, setting up ReLU layers. It has all the scene in convolution layer setup architecture. Now, as after loading and we have run it, we got the accuracy rate. I'll show you. So it starts with 10.23% of accuracy in the first step, and it goes to the it was 10%, and it goes to nearly 40%. Um, I'll again go to the my report to explain you furthermore. Now this is the code I was explaining you before. It has data directory, load data, data dictionary for the batch or the files, and how a single images we use matplotlib for the visualization. Then supporting function rearrange data, setup of images, make it like for the convolutional layer, setting of image data is calling cipher helper class. Then after that we have all the ReLU layers, pooling layers, and build convolutional layer network. In this we have the all after running all the test cases and the layers help us to find the accuracy. The first accuracy in zero step was for the first layer was 10% 23, and it goes for the first evaluation it came to 40%. Then at the end accuracy it was 64.8%. Now I'll go to my report to explain you more about my new data. So at the end for this, I'll I'll tell you about the report, like what I got from this while reviewing our convolutional neural network models evaluation. It learned using CPART and dataset, and we watched how improved data during each segment. At the beginning step 0, as I said before, it didn't perform well. It had accuracy of only 10.23%. This was forcing as it was at the start of the learning phase and didn't know how it will identify features in picture. Just by step 100, we saw an increase. The accuracy jumped up to 40%. This confirmed that our model was beginning to recognize pattern within the CFAR10 database. As we continued teaching the model, things kept improving. By step 200, the accuracy rose to 46.06%. At step 300, it was up to 48.57%. This constant growth showed that model was getting better, and model was getting better. But by step 1000, it was 58%, and by reaching 60.9% at 1100, and at the end, it raised to 64.0%. Then, when we compare with the neural network with the MNIST, it has 77 black and white pictures of handwritten networks. At first, our computer model struggled with this task. It began with low accuracy. Still, quickly it started started to understand, reaching nearly 40% to accuracy by 100 step. By about 300 3000 step, the model got an excellent result of just over 99 accuracy. On the other hand, C410 dataset is a collection of 60,000 colorful pictures of 10 diverse categories like animals and cars. This task was a lot harder. The model had a tougher time with this complex dataset, starting with just around 10% accuracy, but after a lot of training, around 5K steps, the model accuracy reached to 64%. In my part 6, we have improved convolutional layer. As if you want our CNN to better know the CPART10 dataset, I mentioned the adding this layer. This layer views the images, then include an additional layer that zeroes in on the key points. This is similar to giving the model a fresh pair of eyes. This way, it can catch more elaborate details and see complex patterns. In my improved design, I boosted its smartness by inserting another convolutional layer equipped with 64 filters with size 5 by 5x by 5. It uses ReLU activation for improved feature. Also, I have added max pooling layer. It makes the feature extraction more accurate. I have also added a flattening layer. It helps to prepare the data for fully connected layers. I have included a dropout layer for balance. It skips inputs during training, so it doesn't overdo it. The final stage is the out layer. It's an FC layer and uses a dropout layers output for exact prediction. In training phase, the pattern dataset was sorted using CFR classes. All necessary variables were set to set in the tensor procession. We ran a loop for a set of 5K as same as before. The next batch method was used to get training batch data batch. This batch was then used for train the network. In this, as mentioned above, now I'll explain the code same as before. These are the same code as we have uh, mounting the path and then training the data loading and using matplotlib and using several images with understanding the support function and encoding with one hot format. and it reached the accuracy of 66.5%. Um, so as we tested an improved convolutional layer network model on C14 dataset, this upgrade model had extra extra layer for pooling convolution. The result came out to be decent 60 to 65% accuracy range. For the start, with no turning step 0, it showed 8 to 8%. With we had 66.5% by step 4.9K. In conclusion, the project demonstrated the robustness and effectiveness of convolution neural networks in image classification tasks. Throughout the project duration, we successfully trained and fine-tuned the model, enhancing its accuracy. This distinct results obtained from the MNIST and CPAT dataset underscore the complexity of the data and the significance of tailored model architecture. The findings from the CNN are the powerful tools for image differentiation and pave the way for future research aimed for optimizing model precision and efficiency. As you can see in this also, and that in summary, this undertaking uncovered numerous insights for utilizing CNN to order pictures and enhancing neural systems, smoothing out the way and more analyzing trials later on. Thank you.